Alright, so we're going to talk more about acids and bases later, so I'm going to keep this pretty simple. Um, I've snuck some in at some point, I know. Oh yeah, carboxylic acids, amine groups being bases. Those are weak acids and weak bases. So we're only going to deal with strong acids and strong bases right now. And so what acids do is they release H plus into solution, and bases do the opposite. They remove H plus ions from solution. And we'll build on this more later. But, there's like addition and subtraction, multiplication and division, dehydrogenation and hydrogenation. You got these reverses. And so what these guys will do is if you put a strong acid and a strong base together and perform a reaction, and it'll be a very, very exothermic reaction. Like you will get some hot water, and it'll also be salty, which we'll talk about. So you get some strong acid and some strong base. And we're not going to worry about the difference between a strong and a weak acid and a strong and a weak base right now. We're going to leave that for a section later. And what you get is water and a salt. Okay, so here's what we're talking about. Here's an example. Hydrochloric acid plus sodium hydroxide. This is a strong acid. This is a strong base. But all you're looking for, here's how you're going to ID these. Guess what we get? Well, I'm going to get a water, and I'm going to get NaCl. So this guy and this guy, this is going to be an H plus, this is going to be an OH minus when we dissolve them in water, because these are both aqueous, so these have to be aqueous chemistry that's performed. So we'll get some dissolved salt at the end as well. So the salt is aqueous. You don't just get like a chunk of insoluble salt, unless you use the right stuff, but don't worry about it. We didn't talk about solubility rules. But yeah, so we put these together. Guess what? These are going to be attracted because they're opposite charge. You know what happens when you put two hydrogens and an oxygen together? You get water. Yeah. You can get different salts. If we combine, say, HBr and potassium hydroxide, both aqueous. This again will be an acid, this will be a base, but that's not going to be how you ID this, because guess what? If I show you this much, you're going to have a hard time. So it's just know it when you see it. And what you're going to see to tell you this is I'm going to have a water, and I'm going to have a salt. How do you know that's a salt? It's got a metal and a non-metal. It's an ionic compound. Salt equals ionic compound. That's right. Being able to ID an ionic compound just came back into the rule book. That's right. You thought that idea was dead? No, you gotta know. And so when you want to ID an acid-base reaction in this class, don't even look at the reactants. Just look at what you get on the products. That's what I'm going to throw at you. I'm not going to do weak acid, weak base till we get to that section. So you're just looking for water and salt right now. That's how you know what an acid-base reaction is. And you don't necessarily get one water. You can get more. We can have another example here. We can do sulfuric acid. Cheapest acid you can buy, by the way. Literally flows out of old decommissioned mines. Mine runoff is extremely acidic with sulfuric acid more often than not. And then it dissolves a lot of metals and stuff. And can really wreck the environment. But if we write the balanced chemical reaction for this, we'll get, let's see, I need a base here. What should I use? We'll use sodium hydroxide again. I'm going to need two of them here for balancing reasons, which means I'm going to get two waters. And I'm going to get Na2SO4. So we got metal and a polyatomic ion. So that's a salt. That's water. So again, just look to the right hand side of the arrow. That's how you know it's acid base. And we're going to talk about this more when we talk about pH, which will be in the very next section. It's amazing how they're kind of leading into each other right now. So I'm going to leave it here for introducing the topic, and then I'm going to have, this is going to come up in the next video as well, because I'm going to break down all the reaction types we've talked about and make sure you understand how to ID what is what between different reaction types. So hopefully it's clear to you how you ID an acid-base reaction. You don't look over here, keep your eyes to the right, and just be comfortable recognizing a salt, recognizing an ionic compound, and hopefully you're familiar enough with water now that you know to look for that too. And remember, this isn't the only one with water. They could show up in other reaction types, but this is the one that'll get you water and salt. Okay.